All right, good morning, everyone. As we start into kind of talking and finishing up our energy unit, we're going to move into talking about circuits today with electricity, and then we'll move into talking about magnets and how magnets and electricity can both create an electrical charge and a magnetic field. And then finally, at the end of this week, we'll talk about that radiation that we've been discussing with the electromagnetic spectrum and how that, once again, is energy that is moving through different types of systems that sometimes doesn't need a medium and can also create a magnetic charge or impulse too. And sometimes that can be really, really strong with high frequencies, and sometimes it can be really low with low frequencies. So today we're going to just be looking at our currents, and we will talk about a lab that we may be able to get to when we get closer to coming back to school. If not, that's okay. We are going to be looking at one of our simulations on PHET Colorado today, where you'll be creating your own circuit there and then drawing it out and submitting it back to me. So kind of practicing some of those tools that we went through last week. So on Canvas, go ahead and you're probably already there. We're going to go to energy. And I did link all this also in assignments underneath your calendar. But just as always, if you go to our notes sections, we're going to be looking at current notes. No pun. You can pull that up. As you can see, this is a doodle note activity where, I normally would just give this to you. However, we can't. So I do have it downloadable on Canvas if you want to download it and then fill it in, or you can just get out a sheet of notebook paper and kind of fill it in as we go along. I will be underlining a couple of things here and there for you just so that you can kind of get them down and then have a good concept to be able to help you with the actual circuit making portion of the lab. So let me move myself a little bit. There we go. So that we can see. Perfect. All right, so once again, we're going to be talking about circuits today. And so if you remember way back last week when we started talking about static electricity, we definitely were talking about our protons who have a positive charge, our neutrons who have a neutral charge, which are housed in that nucleus, and then circling around the nucleus, we have our electrons with a negative charge. And remember, they're circling everywhere. It's not just like a nice little 2D pattern where they're just making one orbit. It's like 3D. They're circling every which way that they can go. So electricity is now taking those protons and taking those electrons and almost making them flow in a pattern. So we're going to be using our really good conductors of electricity, so our metals, to help us use this as a current to go through one wire to the next. And you can kind of see that here. And that's what we're going to be talking about, is that idea that if you have an energy source such as a battery and you hook it up to wires and then you send that through, we can create this little resistor here to heat up just enough to grow just a little bit. So let's kind of look up here and just get some important pieces of information down. So first, electric charges flow through in a circuit throughout a conductor in the control. So electric charges flowing in a circuit through a conductor in a controlled way, meaning the energy is starting here. It's going to move through the wire. It's going to reach this little metal part, which is going to send energy to our resistor, which allows it to light up to produce energy. It's doing work. Once again, all these things that we've been talking about. And then it's going to move back through in a nice little circle pattern. This here is a switch. Kind of think about it just as like a light switch that would be on your wall. You can turn the lights on, you can turn the lights off, and you open and close the system to allow the energy to stay connected in a nice circular pattern, or it can close it off and break that so that there's a missing link that allows the lights to turn off, if you want to think about it that way. Once again, though, if we're looking right here, this is probably the biggest concept that we're going to be talking about is electrical energy is provided by electrons. Once again, it's those electrons that are moving through the system fast and slow that are allowing any of this energy to kind of move through a whole system. So let me repeat that again. It's just really important. Get it down, start, underline it. Electrical energy is provided by electrons. As we move through the next couple of days, we're going to talk about different types of energies: light, stove, radio. These are all different types of radiations that are really important, and we'll get to them as we move into radiation with the electromagnetic spectrum. Today, though, we're going to stick with this mechanical energy right here and how that energy is, coming back, there you go, through the energy and how it is mechanical. And remember, once again, that has to do with the distance. So if we have electrons and protons that are really close together, that's going to create mechanical energy, allowing things to go through a system. So let's kind of just talk about our conductors and energy sources and our load and all these different things. So first we're going to talk about just this Typically, electrical cell converts chemical energy into electrical energy. Chemical energy meaning that you have the metals in a battery. So if you think about a battery, sometimes you might hear them called a alkaline battery or sodium. There's all these different ones, especially if like you're thinking about the periodic table. Most of those first column elements, sodium, alkali, boron, those types of elements are going to be found in batteries because they're highly combustible. I almost want to say they have a lot of energy. So they're converting that chemical energy. They're allowing those electrons to pass really fast. They're very unstable, and it allows it to create that electrical energy. So let's jump over here to right here where it says creates a path for electrons to flow, usually in metal. So we're going to talk about these wires right here. So we have our energy source that has the electrons to be able to flow through, but they have to have a path to travel through somewhere, and that's what our wires are. It's create a path for electrons to flow, usually in metal. Copper is probably one of the better ones. Tin, aluminum, sometimes gold, all of these are found in different types of wires to allow them to move through. If we jump down to let's talk about our load here. I'm going to move this over here just a little. This is our load right here. So a device that converts electrical energy into another form of energy. So it's just changing it from electrical now back into mechanical. And then our whole, let me jump over here, sorry. And this is our switch. Completes or disconnects the circuit to control the flow of electrons. So just think of a switch. Once again, if it's turned on, it's allowing the whole system to run on through. If it is opened up and broken, that means that it's stopping the electrical flow. It's going from here to here, and then from here all the way over here. And the whole circuit, once again, is a continuous path. It allows it to move all the way through. I'm going to skip over this page here, and we're going to move into this page, which is going to allow us to talk about our two different types of circuits that you're going to see today as we move into the Colorado simulation. So the first is our series circuit and our parallel circuit, but let's just talk about a couple of pieces of information here so that you feel comfortable with a couple terminologies that you'll come through the next couple of hours as you work through the PHET. So this one says, how does current flow through a circuit? So there's two different types of ways. We can have our direct and alternative. Sometimes you'll hear it as DC, sometimes you'll hear it as AC. Direct is just current flow in one direction, start to finish, kind of like a track, start to finish. Whereas our alternative is sometimes it can have a reverse. It can go one way and then maybe jump back and go another way. And sometimes it can even have parallel ways. This would be a great example. Your house would be an alternative current. You have some lights that can be turned on with one switch, and then you have a whole bunch of switches. Not like you just turn one and the whole house lights up. That would be a direct current. You have alternating. So you have a box somewhere down in your basement that obviously has all the wires coming from everywhere down into it. So I'm going to think of it as like the control panel or the mother load of your house. And if something blows, you can go down there and flip the switch and kind of recharge everything. But that's kind of the idea, is that we're looking at alternate currents. Some of that can even just like Christmas lights. Sometimes if you think about it, if you have a Christmas lights where one bulb and the whole thing goes out, one bulb blows and the whole thing goes out, that is a direct. But if you have alternate, that means that maybe one light bulb goes out and a few do, and then the others will stay on. So we're also going to talk about these two different terms right here, conventional current and electrical current. So conventional current is the direction a positive charge would take in a current. So just think about when you are putting batteries together, you have the positive and the negative that have to go together. That's creating that energy, allowing those electrons to move through the system. So a direction a positive charge would take. The other one is the electron flow and the movement of electrons through a negative terminal. So we can have positive charges, and then we can actually have those electrons kind of, remember, skipping and jumping on those outermost shells to kind of keep moving from one system to the next. But today we're going to mostly focus on these two terms, series and parallel circuit. So a series circuit pretty much just looks like a nice little loop around where the current goes through each device in a sequence. The energy leaves the battery, the current travels through the wire, it lights up the light bulb, the little resistor right here, and then moves through another wire, lights up that light bulb, and the switch is closed, allowing that circuit to move all the way around and through. Whereas a parallel circuit, you can see it kind of looks just slightly more complicated, but it allows for one light bulb or both light bulbs to be on or off. It can have different types of mechanisms behind it. So a parallel circuit is a current splits. Some goes through one device and some goes through the other. And you'll get to build that today in the simulation, is that you'll have your battery, your switch, and you can have some of the wires going to one. And when you close it, it will allow maybe this one to go on and this one to turn off, or both of them to go on. And when you open it, only this one is going to stay on and this one will go off. And once again, that's giving that alternating current, your AC. So that's what we'll be looking at. You will hear the term volts a few times pop up, and that just has to do with how much energy is in that battery. So think sometimes you have a very small one, and then you have some bigger batteries, and then you can even get up to things such as like the particle accelerator that we talked about, and other different types of things that have even more energy. So the more voltage, that just means the higher the kinetic energy that battery can have. So I want you to go ahead and try to log into PHET. There is also a document that goes along with this, and get started. Thanks.